Hello everyone, welcome to CV Study Lab. Today we are going to see Greek alphabet. The letters in Greek alphabet looks very complex, and when we ever study them with our normal scientific things, we get very confused at how to write them. Is it any correct way to write them? So let us study how it is written today, as well as we are also going to see that why do we need Greek alphabet to written it as the scientific notations. So in English we have lot of letters though, but they cannot be used every time as a scientific notation. While writing a statement, it may be present as a preposition or some other article. So instead we can use Greek alphabet as one of the helplines. So now let us see each of them. So as English alphabet start with letter A, here also it's alpha. So they are written in the same way, the capital one as the small one. We have some of the symbols may differ and the capital as a small, like in omega you can see that the capital one is different from the small one. So now let us start with writing. So first one is alpha or A in English. So the capital one just resembles your A in English, whereas the small one looks like this. So it is basically used as proportionality symbol also, and alpha is used as many constant. Okay, you can go through any physics or radioactivity book which has this alpha as a constant. Now coming to B or beta. So beta can be written as like normal B, but the line is getting extended, that's all. And the capital beta is same as capital B in English. Now capital gamma looks like a half T, which is not usually seen though, and the small gamma looks like this. So some people write like this, some people find write like this. So anything is okay with you, but the thing is you should understand it. Okay, now coming to delta. So delta is the one which is used by chemists whenever they require heat in any reactions. So they are very familiar with this. And delta, it's like a S, and you protrude that particular ending to make it as a circle and join it at the center. This delta, the capital delta and small delta. Now coming to epsilon. So capital E is same as capital epsilon, whereas the small one is just a mirror image of 3 in normal numeric alphabet. Now coming to zeta. So usually zeta is not used everywhere, but it's like in very unique places. I may not remember particularly, but you should. It's present in somewhere. Like I've seen it in many mathematical books as a way to represent some functions or formulae, but I'm not sure about it. But the capital zeta, it's used to represent many things. Okay, so now coming to eta. So eta is just like the capital eta is like the capital H in English, whereas the small one looks like an N, and that N got a tail there. Yeah, it's like a cursive tail, right? So it's just easy. Now coming to theta. So without theta, any angle will be imperfect, right? So theta is just like the small one is just like this 0, but a horizontal line in between, whereas the capital one is just like an O or a circle you can say, and a H drawn in between. The capital theta is rarely used, or sometimes it is used when you have to differentiate two different angles at the same time. So use one capital theta and small theta, but instead of theta you can use phi or something else. Now coming to iota. So iota is the capital I as capital iota is same, but the small one is just without the dot. So if I write this iota, and if I write this the dot, it means small I in English. Then coming with kappa. So capital K is same as capital kappa, but the small kappa is different from this because it looks like this. And some people just write like this also. Both are correct, but better you go with this one because sometimes we confuse it with a small k, or you can say the capital K. So better going with this is a better one. Now coming with lambda. So lambda is in capital, it's written different, it's small written different. So many people confuse that which one is actual lambda, but it's actually capital and small one. So this capital one is used for molar conductance and many other conductance in chemistry, whereas the small lambda is used in wavelength and also in some very conductance like limiting molar conductance of some ions. So it's called Rush law. Then coming to the next one, that is mu. So capital M and capital mu are same, whereas this other one is like U and the line is protruding. You can draw like this, or you can just, if you are very much better with the Greek alphabet, you can do it very easily. Now coming to the nu. So nu is different than what we saw as mu. So mu is mu and nu is nu. So there is many people just mess it up, like they pronounce it both like mu, it's mu, it's mu, it's new, it's new. So they do not get the difference. So do be careful with that. And this is like used for frequency. So many people draw like this also, which is actually wrong because it looks like sometimes it looks like gamma. So better draw like this, or you can draw like this also. It's up to you. It looks like a V, but it has a small curve over that ending. Now coming to xi. Xi is particularly not used, but you would have heard many times because it is actually confused with the other letter chi. So some people think it's a xi, but it's actually not xi. And xi is very used in mathematical form. I have seen it everywhere, and I also have seen it in normal quantum mechanical things. So it's just like an E, but it go like this, and many people do not use this symbol more, except in some scientific constants though. Now coming to Omicron. Omicron is again the small letter O and capital letter O, don't worry. Then come to pi. Pi, the capital pi just looks like a it's like a wall thing, okay, but the small one looks like different. It's like the wall has not ended perfectly, it has like curves. Yeah. Then coming to your rho. So a capital rho just resembles a capital P, whereas the small rho looks like a P with no head. Okay, you can just differentiate this. Okay, so this thing isn't present here in the normal rho, and you can write like this also, no offense. If you can understand it well, then better go with it. Okay. Now coming to sigma. Sigma has three forms, so you may get confused with it. So mathematicians use this sigma for summation, okay, and many people use this sigma for many other things in very various signs though, and this sigma is rarely known. Okay, so even though these three sigmas are present in sciences, but all the three have various meanings in every time, so better do carry your sigmas well. Then coming to a tau. So the capital tau just looks like capital T in English, and then normal tau is like this. So you can write like this, or you can just put like the J. It's up to you. So writing like this makes you be much comfortable because you can easily differentiate with your normal T. Now coming to your epsilon. Epsilon is not used very frequently because it's just resembles a U. So it's, and also you can see it's a kind of a U thing, right? And the capital epsilon looks like Y, whereas the small one looks like U. Then coming to phi. Phi is again used as the angle, or you can say many other things for some constants like in Hess law, or you can say Lenz's law. Okay, in magnetic things, induction thing, you have phi. So for also you can see the capital phi is different from the normal phi. So capital phi is written like this. Okay, so the small phi is much easier. It's just a circle or an oval with a vertical line in between. Now coming to chi, so many people consider it as x, but no, at many area it is chi, it's not xi, it's chi. So the capital one is just looking like x, but the small one is it's not, it's like x, but it is not. Yeah, it's chi. So mole fraction is chi, it's not x or psi. Many people confuse it with both things. Now coming to psi. Psi is like a Atlantic king's trident. Yeah, so it looks like a trident though, but you cannot differentiate the capital psi and the small psi. Even though you can put like this for that, but still it's a hard work to write in like exams. You cannot just write capital psi, small psi. No, you can go with this psi though, it's very easy. Okay, and very convenient to write also. Now coming to omega. So omega is maybe the first symbol you would have learned in from your 9th class about the resistive with resistance. So it's like the ohm, and you would have also saw it in your normal symbol, electric symbols, where you draw a bulb like thing like this. So it's kind of easy though, and it's a capital omega, whereas a small omega looks like this. So it's very popularly used in your normal physics, actually in electricity, as well as in your kinetics, where the motions are talking. Okay, so this angular motion you have, so the angular velocity is represented by omega. So all these Greek alphabets have their own introduction as well as own things in the particular way in science. So do not meddle with them. Okay, do not just have the idea of that all are same, they have the same meaning, they may have some meanings at here, some meanings at there, so they may vary. Okay, so even you can see rho has many meanings. It has somewhere it is called as a density, it may be called as rho h at somewhere. Okay, it may have like different point group also, so we cannot tell. So in this manner we have learned about Greek alphabets very nicely. I'll put a short video as a just giving lectures.